All right, let's take a look now at Chapter 5, our unit circle approach, Section 2, and revisit some of the things that we've talked about before with trigonometric functions. Not only do you need your calculators, also have that note card handy. So again, we're going to talk about the basics, how to find values of our trigonometric functions, and a lot of those same identities we talked about last time. So from a unit circle approach, again, we have our circle centered at 0, 0, a radius of 1. So at any point on that circle, we're moving around counterclockwise. If t is positive, we should be able to find coordinates of those points. It's kind of strange here at the beginning. Sine and cosine are treated differently than tangent, cosecant, secant, and cotangent, because basically sine of t is the y coordinate of that point. Cosine of t is the x coordinate of that point. And it's that straightforward. That's why they started with this approach here of looking at finding what those coordinates are on that unit circle, because it's a very simple translation then from the x coordinate of that point is the cosine of t, the y coordinate is sine. Now people get this confused, people get lost. Put aside our traditional order in which we talk about trigonometric ratios with SOHCAHTOA and that. Just for a moment, consider the terms sine and cosine. If you put them in alphabetical order, cosine actually comes before sine. Hey, what do you know? X comes before y. Okay, so if you can get past that, sine is the first one that we always talk about. Sine is the y coordinate, cosine is the x coordinate. And then again, we've talked about tangent is sine divided by cosine, so tangent is y over x, provided of course that x isn't 0. And then we have our reciprocal functions there. So cosecant is 1 over y, secant is 1 over x, cotangent is x over y. So find the 6 trigonometric functions for each real number t. So if t is equal to pi over 3, well, okay, for pi over 3 on our unit circle, that has the coordinates 1/2 square root of 3 over 2. So that means sine is square root of 3 over 2, the y coordinate. Cosine of pi over 3 is 1/2, the x coordinate. Now tangent, yeah, a little bit of work there, square root of 3. Cosecant, flip it upside down, put it in simplest radical form, 2 square root of 3 over 3. Secant, well, the reciprocal of 1/2 is 2, that wasn't tough. And cotangent, again, a little bit of work there to put it in simplest radical form. And yes, you should have all of those on your note card. But again, they're trying to show you here how really simple this should be if we understand the unit circle and if we know what those points are, what those coordinates are. Speaking of your note card, here's one we haven't filled in yet. Okay, you should have on that top line 0, then we have pi over 6, pi over 4, pi over 3. The fifth one down should be pi over 2, 90 degrees, But at this point in time, it's blank. Well, now we can fill that in, because we know for rotation up to pi over 2, at the top of our unit circle, that's the point 0, 1. So sine is 1. Cosine is 0. Wait a minute, they kind of skipped something there, didn't they? Tangent is sine divided by, whoops, cosine. That would be 1 divided by 0. That is an undefined value. That's why they skipped it here initially. Cosecant is the reciprocal of sine, so that's 1. Yeah, I don't like the way they did this here. Tangent is undefined. Secant, you'd have to do 1 over 0. The reciprocal of cosine. That's undefined. But isn't it really strange how this works out? Since tangent was undefined as 1 over 0, cotangent x over y is 0 over 1, which is 0. That's a real number. So again, if you concentrate here on this bottom row, don't put dashes. Put those as undefined values. And then once you do that, then you can come back up to the top. Again, that's the point 1, 0. So our x coordinate sine, our x coordinate is cosine, that's 1. The y coordinate is sine, that's 0. And tangent, sine over cosine, 0 over 1 is 0. And our cosecant is also undefined. The secant is the reciprocal of cosine, so 1 over 1, well, that's 1. And if tangent is 0, the cotangent, the reciprocal of that, is undefined. Again, it's a video. You can pause it. Yeah, there are going to be some things anytime when t is equal to a multiple of pi. That leads us to domain and range. For the domain for sine and cosine, you can put in any possible number. It's all real numbers. And we should get a number, as we've talked about before, between positive 1 and negative 1. We'll get into, I wouldn't worry about this too much right now. We will later in this chapter take a look at the graphs of these. So domain and range is going to become clearer once we do that on a different day. It is not this day. So then we get into, hey, look at that chart, looks familiar. In quadrant 1, all of the functions are positive. In quadrant 2, if we just do the primaries, sine. In quadrant 3, tangent is positive. In quadrant 4, cosine is positive. It's almost like you should take some kind of a mnemonic device and make up some kind of a sentence to help you remember which ones are positive in which quadrants. So now we're going to do much the same thing that we did before. Now remember, in section 1 here, there was a whole big thing there about finding reference numbers. And we just talked about positive and negative in which quadrant. So again, we're going to put those together and find exact values here. This is not a calculator exercise. So for the cosine of 2 pi over 3, that puts us solidly there in quadrant number 2. If it's quadrant number 2, we're going to take pi minus t. So pi minus 2 pi over 3 gives us a reference number of 1 pi over 3. So cosine in the second quadrant is negative. So basically we can say that the cosine of 2 pi over 3 is equal to the negative of the cosine of 1 pi over 3. From your note card, we know the cosine of pi over 3 is 1/2. So the cosine of 2 pi over 3 should be negative 1/2. For the second one there, they asked us to find the tangent of negative pi over 3. Well, negative pi over 3, we rotate around clockwise, only a distance of pi over 3, that puts us in quadrant number 4. So the reference number for negative pi over 3 is 1 pi over 3. Tangent in quadrant 4 should be negative, so we can say that the tangent of negative pi over 3 is equal to the negative of tangent of positive pi over 3. From our note card, tangent of pi over 3 is square root of 3. So the tangent of negative pi over 3 is negative square root of 3. And then the sine of 19 pi over 4, wait a minute, that's more than one full rotation. So we look for something that is coterminal. Okay, so 19 pi over 4, we could subtract one full rotation, which would be 8 pi over 4. And we could subtract another 8 pi over 4. And that gives us a difference there of 3 pi over 4. So 19 pi over 4 and 3 pi over 4 are coterminal. Their coordinates are the same. So again, I love how they do this. Sometimes it's like, okay, we spun around once, we spun around twice, and then we've got a leftover of 3 pi over 4. We end in quadrant number 2. For 3 pi over 4, our reference number is going to be pi over 4. Sine in quadrant number 2 should be positive. So for the sine of 3 pi over 4, it's going to be the same as the sine of 1 pi over 4. That's going to be positive square root of 2 over 2. This would be a really good time for you to take your calculator and put it in radian mode. That's what we are going to be using here the vast majority of the time for the rest of 5 and for the next chapter, which I'm keeping secret for right now. So again, for those of you that are actually using, sorry, let me get that out of the way, the document side of things. So you go back to your home screen here and you go down to option number 5 for settings. I want to change the setting on my current documents, so that's option 2. And down to angle, go back to radian. And then I think for you guys, you've got to go all the way down and click OK. And then if I just go back to 4, my current document, I now see that this is in radian mode. For those of you that insist on just using the scratch pad, my goodness, you're missing out on so much of this. All right, sorry, I'm going too fast here. If you're in Scratchpad and that's not in radian mode, I believe you can click on the document button. Although you're not doing the document, you can go to 7, which is settings, and then option 2, and that's where you can change it again. So then you can take sine, cosine, tangent of anything at all. So sine of 2.2. Now notice here with this slide, the degree symbol is missing. That means the sine of 2.2 radian. So if we do then sine 2.2, that's not one of our special angles. Hopefully you can understand 2.2 has got to be in the second quadrant. Sine in the second quadrant is positive. Yay, our calculator agrees with us. Cosine of 1.1. Again, your calculator will do that for you in a heartbeat. What they have there for examples C and D, you can pretty much ignore those because your calculator will directly do all 6 trig functions. You don't have to worry about reciprocals of this or flipping anything upside down like that. Now, you haven't done enough of these to understand the exact relationship going on here. This nice little part of the unit circle diagram, kind of interesting. The sine of negative t is going to be simply negative y, which is the negative of sine of t. Cosine of negative t, that's going to be our x-coordinate. It doesn't matter if you're up there in the first quadrant or down in the fourth quadrant. The x-coordinate is still going to be positive, so the cosine of negative t is equal to the cosine of t. Tangent operates much the same way that the sine function does. So in this case, the cosine function seems to be kind of an oddball, which is the exact wrong way to think of it here, because the way we define it, cosine is an even function, because the cosine of negative 36 degrees and the cosine of positive 36 degrees are going to be the exact same value. But sine of negative 95 is going to be equal to the negative of the sine of positive 95. Or if we're just doing, I even don't feel right being over here on that scratch pad. Just doesn't look right. The sine of, this is in radian, let's say negative 1.2. And the sine of positive 1.2. Same decimal approximation, but for the positive angle it's positive, for the negative angle it's negative. Again, the negative 1.2 will put you down in quadrant 4. Sine in the fourth quadrant should be negative. Okay, but if I do the same thing with cosine, do the cosine of negative 1.2 and the cosine of positive 1.2, they're the exact same value, exact same sign. Both of them have to be positive. Let's try cosine of negative 2.2. That should put me in quadrant 3. Again, it's negative. I'm going around clockwise, so that's negative. But if I do the cosine of positive 2.2, that'll put me in quadrant 2, and that's also a negative value. Okay, so positive or negative for cosine, they're going to be the same. And if we're saying that cosine is an even function, same thing is true for secant. The other four are considered odd functions. What's the sign of negative pi over 6? Well, again, from our chart, we can say that for pi over 6, the sign is positive 1/2. So for the sign of negative pi over 6, it's going to be negative 1/2 because sine is odd. What's the cosine of negative pi over 4? Well, sine is an even function, so the cosine of negative pi over 4 is going to be the exact same value as the cosine of positive pi over 4, which again, from your chart, positive square root of 2 over 2. And then we get into G. You've seen all of these before. Tangent is sine divided by cosine. Sine squared plus cosine squared is equal to 1. Okay, I imagine that you have many, if not all of those, on the back of your note card. Say cosine of t is 3/5, and t is somewhere there in quadrant 4. Okay, not surprising that cosine is positive in quadrant 4. Find the values of all of the trigonometric functions. All right, so if we know that cosine is 3/5, back to our unit circle, we could do it that way because we know that cosine is the x-coordinate. Or we could rely on dear old Pythagoras. Three-fifths squared should give us 9 over 25. Subtract that from both sides. So 25 over 25 minus 9 over 25 will give us 16 over 25. Take the square root. Hey, look at that. It's square root of 16, 4. Square root of 25 is 5. Plus or minus. Now we got to go back, read, if we're in quadrant 4, should that sign be positive or negative? So we just figured out sine of t is negative 4/5. They gave us that cosine was positive 3/5. Tangent is sine divided by cosine, so negative 4/5 divided by positive 3/5 is negative 4/3. And then for the secondaries, take the reciprocals. That's it. Again, scroll down to the bottom there of your notes and you will see your assignment ready for you there. Please show some work, especially those where you just look it up on your note card and make some indication of your acknowledgement. This is in quadrant 3. This should be negative. Our reference number is this. And that's why we get negative square root of 17 over 98 or whatever it is, okay? Show some work. This is going to be really easy to skip over that. Please don't be that student. All right. I will talk to you soon.